In this video, we will talk about the basics of the support vector machine, which is often abbreviated as SVM. This is a more advanced classification model than logistic regression. Let us start with a motivating example. Here we see a classification problem with orange circles and purple triangles. We see two decision boundaries, a green boundary and a blue one. My question for you is, which model do you think will perform best? Take a moment to think about this, pause the video, and afterward we discuss the answer. Okay, welcome back. Okay, so I think most of you would say the green boundary. Why? Well, it has a bigger margin of error. If the orange circle moves around a little bit, it might jump over the boundary by accident, while the green boundary has more distance to all points. This motivates the support vector machine. It tries to find the boundary with the large margin of error. This is closely related to the concept called margin. The margin is the distance from the closest point to the boundary. This distance here is indicated on the slide. The objects that are closest to the boundary are called support vectors. So what is the support vector machine going to do? It will find a boundary that has the largest margin. Okay, let's define this mathematically. Here on the slide we have the equation for a linear classification model. For the SVM model we usually define the boundary at 0. So if we set this equation to 0 and solve it, we find the decision boundary. I've indicated this in the plot with the equation. Now how do we obtain the dotted lines here? Well, one option is to define these lines by setting the equation to +1 and -1. Solving these equations, we obtain the dotted lines that go through the support vectors. With this formulation, we can calculate the size of the margin by taking 1 over the norm or length of the vector W. To get a better understanding of the SVM, I have another widget for you where you can play with the SVM. You will be able to draw a dataset and train the SVM on your data. This widget will also illustrate why the SVM is a relatively stable classifier. Afterward, we will continue with part 2 of this video.